we're going to learn about HA. You might have thought, poor old HA. It seems to be the underdog, right? We make all of our decisions based on HO. Does that mean HA is not important? Well, no, HA is your hypothesis, and believe me, you are going to feel like your hypothesis is important, and it is. So let's spend some time looking at HA, then we're going to look at how HO and HA relate to one another, and we're going to then start talking about the 4 areas under HO and HA. Remember the 4 boxes in that square when we learned about 2 types of correct decisions and 2 types of errors? Well, we're going to map that onto both HO and HA, and then we're going to look at ways of minimizing errors in our decisions. All right, so that's what we have planned for today. So let's look at HA. HA is also a hypothetical distribution. And just like HO, HA goes from negative infinity to positive infinity. Along the x-axis are values of the TS that could belong to HA. In other words, values of the TS that could be representing something in addition to sampling error. Now, you might, if you're, paying close attention, you might have realized something peculiar, because I have said HO extends from positive to negative infinity. HA also extends from positive to negative infinity. Well, that means both HO and HA are going to have values of the TS in common, right? And that's true. In other words, any TS of any size could belong to HO, but it could also belong to HA, right? And our job using statistics is to try and figure out where our TS most likely belongs. Does it most likely belong to HO, or does it most likely belong to HA? Because both are possibilities, but they're not going to be equally probable. Right? You'll see that in a few minutes. Okay, so again, like HO, we're going to have values of the TS on the x-axis, and we can see that those values of the TS that fall in the middle of this distribution probably really truly do belong to HA. Probably. All right, they probably do belong here. And similarly, if we get values of HA that are either in this tail or that tail, well, these TS values could, in theory, belong to HA, but they probably don't. And if they probably don't, that means that, well, maybe it's because they actually belong on HO. All right, so you see what's happening here? HO looks like this. HA looks like this. They both look like this. HO is going to show you the probability for each TS value, the probability that it belongs to HO. HA does the same thing. These are TS values. We can determine the probability of any of these TS values under HA. Just remember that although we could do that, we still, in order to make a decision of sampling error or sampling error plus something else, we still make all of our decisions based on HO and not HA. Okay, so HA represents the probability of getting any TS when there is something more than sampling error. These values of the TS probably do reflect sampling error plus something else. The ones in the tails, questionable. They could belong to HA, but then again, maybe they belong to HO. We're going to find out.